All right, so the second thing that we're going to talk about in this section 1 are now just going to be special number sets. Right, so now what you're going to need to be able to do with this is if you're given numbers, say 2, the square root of 2, 3 over 4, if you're given these numbers, you'll need to be able to define what number set they are part of. All right, so there's different ones that we're going to discuss now in this video, and by the end of this, you'll be able to say what number set 2 is in, what number set square root of 2 is in, and what number set 3/4 is in. And remember, throughout this entire chapter, not just this section, we need to be thinking about this question: how can we define groups of objects? Right? The more we learn in this chapter, the more we'll be able to branch off and give multiple answers and not just one specific answer and say, well, we can define them by calling them sets. All right? There will be certain things that we can talk about. Like even right now, we're going to discuss different types of number sets. So there's different ways that we can answer this question, but we should constantly be coming back to it. All right, so the first number set that we are going to talk about are our natural or our counting numbers, right? And the way that you denote this is that symbol here, like this. All right, so those are our natural numbers. So anytime that you see that symbol, that is letting the reader know that these numbers are part of our natural numbers. And our natural numbers are our counting numbers here, but they are all whole positive numbers. So 1, 2, 3, 4, 5, 6, 7, and so on. So any whole positive number and the number 0. All right, so if you think about it, we're using our counting numbers. Well, if we have objects that we're trying to count, we can only use the number 0, 1, 2, 3, 4, 5. So we have 5 desks in our classroom. We can say, well, we have 1, 2, 3, 4, 5 desks. So we're using our natural or our counting numbers. So anytime you see this symbol, you know that it's referring only to these numbers. So back to our first question that we said that we will be able to answer, this number 2 we can say is an element of our natural numbers because it's part of our positive whole numbers. Right? Now if you look at this number line, they only have these points on 0, 1, 2, 3. They're not drawing any line connecting them because if they did, that would say all the numbers in between. So we're not, 0.5 is not part of our natural numbers because it's not a whole number. 1.25 is not part of our natural numbers because it's not a whole number. So it's all of our positive whole numbers and the number 0. All right? And it's denoted by this symbol here. The next set of numbers that we will discuss are our integers. Now, integers include all of our natural numbers. If you notice, we have 0, 1, 2, 3, 4, 5, 6, but now it includes all of our negatives as well. So integers are all of our whole numbers, whether they're positive or negative, are now our integers. And the way that we denote this is by this symbol here. All right, so our integers include all of our natural numbers, but now it also includes all of our negatives as well. That's why we had the plus or minus. And the same thing as before, there's no line connecting any of these because we're not including any of the decimals. It has to be a whole number. So negative 0.5 is not an integer because it is not a whole number. So integers include all of our natural numbers, but then it also goes a step further, including all of our negative numbers. So if we go back to one of those problems in the very beginning, 2, we said was an element of our natural numbers, which is true, but now we can also say that 2 is an element of our integers. All right? Now there's one other thing that we're going to discuss with this as well, and that is if you see this symbol here, z plus or z negative. So what this integer positive is telling us is that we're only focusing on all the positive integers. So although 0, negative, 1, 2, 3, 4, 5, etc. are part of our integers, anytime it's our integer and then a positive sign in the upper right-hand corner, that's saying we're only focusing on all the positives. And the same thing if we did z and then a negative in the upper hand corner, that means we're only focusing on all of our negative numbers and none of our positive. All right, so with our integers now, we can actually break these down into several subsets depending on what we want to focus on or what we want to look at. All right, so 2 would not be an element of our integers if we're only focusing on the negatives or the left-hand side. All right, the next set of numbers that we're going to talk about are our rational numbers, and they are denoted by this symbol here. All right, if you want to just write it out like this on your test, that's fine with me. All right, and our rational numbers are any numbers that can be written as P over Q, so they're any fraction where P and Q are both integers, and Q cannot be equal to 0, or else we would be dividing by 0, and we know that that's undefined. All right, so it's really any fraction. So now we have 1/2, 3/4, -1/2, etc. All right, so all of those numbers are rational numbers, but so are all of our natural and our integers. Because if I write that number 2, I can write it that it's understood to be over top of 1. So 2 is still part of our rational number set. So 2 is part of our natural numbers, it's part of our integers, it's also part of our rational numbers. And then back to one of the first questions that I asked, 3/4 on the very first page, 3/4 we would say is an element or a member of our rational numbers. All right, now you might think that if we go back to the number line that we had during our integers and our natural numbers, that now we can go ahead and connect all these dots, because now we're dealing with all the fractions. So, right, we got to be able to connect all the dots. That is not correct. All right, we still can't use a number line and connect all the dots for this yet. And that's because there are some numbers that cannot be written in fraction form. And those numbers are called irrational numbers. All right, irrational numbers cannot be written in fraction form. So go back to one of the questions that I wrote on the very first page, the square root of 2. That is an element of an irrational number. Unlike our other ones, there's really no letter that is used to denote irrational numbers. So you would just say 2 is an element of irrational numbers. Square root of 2, I'm sorry. All right, but irrational numbers are something that cannot be written in a fraction form, where both our numerator and our denominator are both integers. So pi is another one that is an irrational number that we will be using. So the reason why we cannot write in this number line is pi we know is 3.14, and that is represented on this number line, but it cannot be represented as a fraction, so we cannot draw a number line to represent our rational numbers. All right, there's one more set that we're going to discuss, and that is our set of all real numbers. Now we can finally use the number line. All right, our set of all real numbers includes all of the sets that we just discussed. Any number that's a natural number is a real number. Any number that is an integer is a real number. Any number that is a rational number is a real number, and any irrational number is also a real number. All right, so all of these are part of our real number set. And we denote this, you can just draw this with 2 lines in the R. That would be fine for drawing it. All right, so 2 is an element of our real number. The square root of 2 we can say is an element of our real numbers. And 3/4 we can also say is an element of our real numbers. So all 3 of those numbers that we talked about in the beginning, they're all part of our real number system. All right, I just wanted to give you this picture real quick. This is a Venn diagram, something that we're going to start discussing very shortly, I believe in section C. And this kind of talks about every single number within this rectangle is a real number, and any natural number we know is an integer. We didn't really discuss whole numbers. We included that with natural, so we can say that this entire circle here is our natural numbers. So any number that's a natural number we know is also rational, because we can rewrite 2 as 2/1. But we also know that any of these numbers, period, are all real numbers. All right, so I think this is just a good, I'm going to get rid of all of the writing I just did. I think that this is a good, I'll cross out whole numbers still. I think that this is a good representation, though, that you guys can look at to think about which sets make up other sets, because natural numbers make up everything else, and also examples of each. All right, that is it for this section. That's it for this video. That's it for this section as well.